Hey, what's going on again? It's Jenkins back with another Jenkivision physics lesson. This time we're going to be learning a whole new type of circuit, and it's going to be the parallel circuit. So with me, I got the Learning Lab, I got Chavez, I got Christian, I got Miss Matt, Gabriella, Tatiana. We've got everyone here. We've got Shantae. We've got the girl that was supposed to leave that never left, Miss Torres. We've got Jaime. We've got Alexis King. We've got Javier. We've got Homero. We've got Vasquez. We've got Venegas. We got everyone. We've got Angel Delgado. We've got the dream team here. So pay attention. This is what you need to move on in the class. Let's start off with a little bit of review. So that first circuit we learned is called the what? That first circuit we learned is called the what? Series circuit. Thank you, Chavez. That series circuit. And to draw that series circuit, I start with the what?
The battery.
The battery. One straight line, another straight line. Positive, negative creates that potential difference. Potential difference. That's the voltage in the battery. Let's say it's 12 volts. It's going to come out over here and this and this and this. All these things. These are resistors, light bulbs, things like that. They provide resistance. And what's the unit for resistance again? It's this crazy symbol. What's that called? Ohm. Ohms. So now we might have a 2 ohm resistor. We might have another 2 ohm resistor and another 2 ohm resistor with 12 volts. The voltage is going to push the current through that. And of course, we've got our Ohm's law, which is the voltage is equal to I, the current, times R, the resistance. All I have to do is add up the resistors. What's the total resistance in this circuit? Someone let me know. 6 ohms. What is the total voltage in this circuit? 12. What's the current then? I have to find it. What's I right here? Something times 6 is equal to 12. 2. That's right. So we've got 2. So the current is 2 amps. The resistance is 2 ohms. And the voltage or potential difference is 12 volts. So simple, so easy. I love it. Now, the bad part about this is this series circuit, like those Christmas lights. If one of these light bulbs went out, what would happen?
Everything will go out.
It would all go out. The circuit will not be complete. It will not push current throughout, and it will not reach the other side of the battery. It won't even start. This is not how we wire our houses, because it would be really stupid for me to turn on my lights and then my refrigerator goes off, or I open the refrigerator and my stove stops working. So I actually wire my house and almost everything else with a different, more complicated type of circuit. And that's what we're doing today. Get your notes ready. It's called the parallel circuit. It's called the parallel circuit. Why do you think it's called parallel circuit? What does parallel mean? Boom, 2 lines, right? So parallel, things that are side by side maybe. Let's see how this looks. I'm going to draw it for you. What do you think I start with? The same thing, right? What do I start with? I'll start with the battery to give me a potential difference right here. And then the circuit's going to come out. This conducting wire is going to come out. And I might have a resistor right here, like a light bulb or something. But guess what I'm going to have here too? Oh, look at this. Instead of the resistors being in series, back to back, right, in a line, sequentially, what's going on here? What's the difference?
They could choose a way.
You can choose. You can choose a path. Look at the charge. I'm a little charge. I'm coming here. What's my choice here?
Go down or
I can go down or I can go over. Perfect. So you can see then that if I turn this off, can the current still flow? No. It can't flow in this path, but can it go anywhere else?
Yes.
Yes, it can. So if I turn this light off, the rest, my sister's light doesn't go out, right? The toilet doesn't flush. This thing right here is a parallel circuit. It's how we wire our houses. These are the same type of resistors. Let's say it's 2 ohms, 2 ohms, 2 ohms, right? And this is the same 12 volt battery. Now, what do you think the total resistance is in this circuit? Over there was 8. I added them up, right? Or 6, right? I added them up. 2 plus 2 plus 2. What do you think it is over here? Do you think I can add them up? No. What do you think? Yes or no? Is it that simple? No. It is not that simple. It is not that simple. Something crazy happens, and we have to calculate the total or equivalent resistance, which I'll say is the total resistance, not by adding 2 plus 2 plus 2, but we have to do this crazy reciprocal relationship. It's 1 over a half plus a half plus a half. All of these right here, they don't add up to the total resistance. I have to do the reciprocal. 1 over the final resistance is equal to 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor. So right now, I want you to go ahead and just tell me the total resistance of this circuit, because it is not 2 plus 2 plus 2. It is 1 over 2 plus 1 over 2 plus 1 over 2. Someone get that in a calculator. Let's get it. Huh?
3 over 2.
What?
3 over 2.
Okay. Give me an actual number. Give me a whole number. Or excuse me. Give me a
1.5.
huh?
1.5.
1.5. So my total resistance is actually 1.5 ohms. So can anyone sort of tell me why I might have less resistance, even though it's the same number of resistors and the same actual rating for the resistors, the same amount of ohms? Yeah, right? And we're going to see that when we build these circuits. This is the parallel circuit. You can find the same things using V is equal to IR. Voltage is still equal to the current times the resistance. But now, if I wanted to know the total current in here, I wouldn't use 2 plus 2 plus 2. I would use 1 over a half plus a half plus a half. That would be my total resistance. I can find I using the same way, right? I can also find the total current in each of these branches, which is what we're going to do over this next week. This is the introduction to the parallel circuit. You need to know it. All right? Hold on one second. Boom. Be sure to mash like and subscribe. Boom.